Long before the first stars lit up the sky, before galaxies were born, something was already there. A monster, silent, invisible, and ancient beyond imagination. The James Webb Space Telescope has just found it. A black hole so old, so massive, it shouldn't even exist. How could a black hole, weighing 50 million suns, exist when the universe was still a newborn? Less than a billion years old. What secret of cosmic creation is hidden behind this impossible discovery? It all began when the James Webb Space Telescope, humanity's most powerful eye on the universe, turned its golden mirrors toward a distant region of space known as Abell. (2744), also called Pandora's cluster. There, hidden behind the tangled light of galaxies, Webb saw something strange. A single point of brilliance, far beyond the cluster, distorted and magnified by gravity itself. Scientists named it QSO1, an object whose light left its source when the universe was just 700 million years old. But when astronomers looked closer, they realized this wasn't a galaxy at all. It was something far more powerful and far more puzzling. QSO1 was first analyzed in early 2024. The data revealed something shocking. This ancient object contained a black hole about 50 million times more massive than our sun. That's not just huge, it's impossible for something that young. The universe itself was barely out of its infancy when this black hole already existed. So the question emerged, how did it grow so fast? To make matters stranger, QSO1 didn't show any sign of a typical galaxy around it. No rich clouds of gas, no sprawling clusters of stars, nothing. It was as if the black hole itself was the entire system. Professor Marta Voluntari, a world-renowned astrophysicist at the Paris Institute of Astrophysics, called it a very odd system. Her words were simple, but behind them lay decades of cosmic puzzles. Voluntari, along with Ignas Judzbalis from the University of Cambridge, double-checked the results using independent models, and the numbers didn't lie. QSO1 truly contained very little mass other than that of its black hole. Imagine a universe where gravity hadn't yet built the first galaxies. And yet, in that darkness, something dense, heavy, and ancient already existed. That is QSO1. To understand why this discovery is so strange, let's travel back 13.3 billion years into the past. The universe was young, just 700 million years old. In cosmic time, that's like a human baby only seconds after birth. Galaxies were forming slowly, stars were fusing hydrogen for the first time, and light was beginning to pierce the cosmic fog. And yet, Webb's infrared eyes detected a massive black hole already waiting there. According to everything we know about physics, this shouldn't be possible. Normally, black holes form when massive stars die. After millions of years of fusion, their cores collapse under their own gravity, creating an invisible point of infinite density. But here's the problem. In the early universe, there hadn't been enough time for stars to form, live, and die to create such gigantic black holes. So, where did QSO1's monster come from? Some scientists now believe that the universe's first black holes didn't come from stars at all. Instead, they may have formed directly from enormous clouds of gas collapsing under gravity, bypassing the entire star stage. These are called direct collapse black holes, a theoretical class of black holes that could form just a few hundred million years after the Big Bang. If QSO1 is one of them, it means we might be looking at one of the first black holes that ever existed. QSO1 lies in a region known as Abell 2744, or Pandora's cluster, a massive gathering of galaxies whose combined gravity acts like a cosmic magnifying glass. This phenomenon, called gravitational lensing, bends and amplifies the light of distant objects behind it. That's why Webb was able to see QSO1. Its light was stretched and focused through the cluster, arriving at Earth as multiple magnified images. Without this natural lens, the object would have remained invisible, forever hidden in the darkness of time. The James Webb Space Telescope's infrared instruments captured QSO1's faint light and analyzed its spectrum. The results were clear. QSO1's light carried the fingerprint of a powerful black hole, devouring matter, releasing radiation across the cosmos. Yet there was no surrounding galaxy to host it, no stellar nursery, just the void. It's as if the black hole was born in isolation, an orphan of the cosmos, a black hole weighing 50 million suns, existing just 700 million years after the Big Bang, is more than just rare. It's a direct challenge to our understanding of cosmic evolution. To grow that large in such a short cosmic time, it would need to consume matter faster than physics usually allows. But Webb's data doesn't lie. The numbers are there, undeniable, precise, and deeply confusing. It's a very odd system, said Professor Voluntary. If there are more like that, it becomes really bizarre. These words echo through the halls of astronomy departments around the world. Because if QSO1 is not unique, then the early universe might have been filled with invisible black holes, long before galaxies even existed. Could these ancient giants be the seeds of every galaxy that came after? For decades, scientists believed that black holes formed inside galaxies, born from their stars. But Webb's discovery may be forcing us to reverse that story. What if it was the black holes that came first? What if galaxies are the byproducts, drawn together by the gravity of those early cosmic monsters? The idea is radical, but so was every great discovery in science. When Einstein first predicted that gravity could bend light, people thought it was madness. Today, that very prediction allows us to see ZO1, somewhere 13 billion light years away. The light of QSO1 still travels through space, each photon a messenger from a time when there were no stars, no planets, no galaxies, only darkness and gravity. And in that darkness, something stirred a black hole that would defy everything we know. The universe, it seems, keeps rewriting its own origin story, and Webb is helping us read the first forgotten chapter. But the story doesn't end here. Because if QSO1 truly is a lone black hole without a galaxy, then it raises an even darker question. How many more of them are out there unseen? In the quiet vacuum of space, something ancient watches us. Its light has traveled for over 13 billion years to tell a story no one was ready to believe. The James Webb Space Telescope has seen it. Astronomers have measured it. And now, the universe demands an explanation. Scene 15, the impossible growth. Narrator measured, investigative tone. How can a black hole weighing 50 million suns form so soon after the Big Bang? The universe back then was a sea of hydrogen, no galaxies, no mature stars, no rich clouds of heavy elements. And yet, here stands QSO1, a black hole that defies time. To reach its enormous size in only 700 million years, it would have needed to grow at impossible speeds, swallowing matter faster than the laws of physics usually allow. Scientists call this super Eddington accretion, a process where a black hole feeds faster than its radiation can push matter away. It's like a monster that eats faster than it burns, growing exponentially while breaking every rule we thought we understood. So maybe ZO1 didn't start small at all. Maybe it was born massive. In 2024, several astrophysicists proposed a bold theory that the earliest black holes could have formed directly from collapsing gas clouds, not from dying stars. These so-called direct collapse black holes may have been the true pioneers of cosmic structure. They were not born inside galaxies. Galaxies were born around them. If that's true, then QSO1 is not just an anomaly. It's a fossil, a surviving relic from the dawn of creation. The discovery of QSO1 may finally explain how supermassive black holes, the ones we see at the centers of galaxies like our Milky Way, came to exist. Perhaps the early universe was filled with tiny, invisible seeds of gravity, forming webs of matter that attracted gas and stars to themselves. Each seed grew, merging and consuming, until the first galaxies coalesced around their gravitational hearts. In other words, black holes didn't form inside galaxies. Galaxies formed around black holes. This changes everything we thought we knew about cosmic history. Before the James Webb Telescope, we could only dream of seeing such distant objects. The Hubble telescope gave us glimpses of early galaxies, but it couldn't see this far. it couldn't pierce the veil of cosmic dust. Webb, with its massive golden mirrors and infrared eyes, can capture light stretched across billions of years. It can see the first stars, the first galaxies, and perhaps the first black holes. QSO1 is just the beginning. If one such black hole exists, then how many more are hidden out there, unseen, drifting alone in the darkness? What if the early universe was full of these orphan black holes, cosmic ghosts with no galaxies to call home? These invisible giants could have shaped everything: the stars, the galaxies, even the cosmic web itself. Every point of light we see today might trace its roots back to one of them. But one detail keeps astronomers awake at night. QSO1 has no galaxy around it, not even faint traces of stars or interstellar gas. It's as though the black hole consumed or erased its host, or perhaps it never had one. Some researchers think that QSO1 represents a stage before galaxies began, a glimpse into a universe where black holes existed first, waiting for matter to gather. Others believe it might be a rare runaway, a black hole ejected from its galaxy after a cosmic collision. But the truth is, no one knows for sure. Without gravitational lensing, Webb would never have seen QSO1. The cluster Abell, 2744, a massive collection of galaxies, acted as a natural telescope, bending and amplifying the light of this ancient object. This effect doesn't just magnify, it duplicates. The light from QSO1 appears in multiple spots, each one a different path through spacetime. Studying these images allows scientists to reconstruct what the universe looked like when it was still young, and to measure how space itself has stretched over billions of years. The James Webb Space Telescope is more than a camera, it's a time machine. Every photon it captures is a story from the past. The light of QSO1 began its journey long before the Earth, the Sun, or even the Milky Way existed. When that light finally reached Webb's golden mirrors, it carried a message, a whisper from the universe's first age. And that message said, there was darkness, and in that darkness, something was already alive. This discovery has forced astrophysicists to rewrite their models of cosmic evolution. If supermassive black holes existed before galaxies, then our current timeline of formation is wrong. The first galaxies may have been drawn together by black holes rather than birthing them. That means the very structure of the universe, the way matter clumped, stars formed, and gravity shaped everything, must be reevaluated. Webb's discovery doesn't just add a chapter to the cosmic story, it rewrites the beginning. QSO1 may only be one of many. The James Webb Telescope continues to scan the skies, searching for more ancient objects, for black holes even older, smaller, stranger. Each one could unlock another piece of the mystery. How did the first structures of the universe truly form? Where did the first light come from? And what role did black holes play in creating everything we see today? Somewhere out there, beyond the veil of time, more ZO1-like objects may exist, each a relic from when the cosmos was still learning how to create. They drift alone, silent, ancient, carrying the memory of the universe's birth. Perhaps, in their gravity, lies the answer to everything. The reason galaxies exist, the reason we exist. Webb's mission has only begun. Over the next decade, it will keep observing the earliest galaxies, the first stars, and perhaps even the moment when darkness became light. With each image, it takes us one step closer to understanding our cosmic origins, and one step deeper into the mystery of what came before. QSO1 is not just a discovery, it's a message from the past, a reminder that the universe still holds secrets we can barely imagine. The first black holes were never meant to be seen. They were born in silence, hidden in darkness, and yet, against all odds, their light has reached us. 13 billion years later, through the eyes of James Webb, we can finally see the ghost of creation itself. The deeper we look, the older the mystery becomes.